Welcome to Python Lesson 19. Continuing our exploration of functions, we're going to see how we can create functions that work off of other functions. So let's get to it. So just as a quick review, just make a font a little bigger. So we've been creating our functions in a separate file, which hopefully kind of differentiates the idea between defining a function and calling a function. So you'll call your functions from the main program, but you'll define your functions in this separate file. In order to make that connection between the two files, we use this from my functions, which is the name of this file, import everything. So that's how we're able to bring in all the code that we write over here to over here. So in this example, in this video, we're going to show you how you can create functions that work off of other functions. So let's start with our scenario. And I also wanted to review a little bit of the language that we're going to use to kind of teach you how to construct a function. So when you see a scenario that says like create a function, immediately you got to think, okay, I got to do DEF. That is how you create a function. And then the very next thing will typically be the name of the function we want you to use. So my sum. Now, regardless of what happens next, a function always has parentheses. And in Python, you have to put the colons at the end. So I would do that automatically, because regardless of what comes next in the scenario, you always need that part. Now we got to read a little bit more of what's happening here. So it says it accepts a list. So when you see the word accepts in the way we structure the scenarios for you, that means those are parameters. Those are things that you have to put here. Now, sometimes we'll give you a hint as to what name you use. Other times we won't. So if you wanted to, you could. Notice how the word turns purple. I would not use the word list. So maybe we could do my list. Notice how it stays black. Anytime the word in Replit, if you see something turn purple, that lets you know that it's part of the language, which is also the reason I used my sum instead of just the word sum, because sum is actually used by the Python language. So just continuing on with our way of translating a scenario to code. So we got the function name, goes right here. Function is def. Regardless, we need the two parentheses. That's just part of the syntax for a function, and the colon at the end. If we see the word accepts, because not all functions accept information. If we see the word accepts, that means we put something inside the parentheses. If you don't see the word accepts, that means you still put the parentheses, just means you don't put anything inside of it. Okay? All right, so continuing on. Now, this is a little bit of review from previous videos. You know, how do we go through a list? And we want to create some kind of a sum. So let's create a variable called s, set it equal to 0. We go through each item in the list. So I can do length of my list. The len function, notice you've actually been working in functions for a while now. The len function actually returns you the length of the list. Because in other examples, you actually saw the number. And honestly, here we can kind of see that it's 3. It'd be wrong for us to put the number 3 here, because then that means that the only types of lists that our function would work with would be list of size 3. So by using this, it will determine as the program's running how big your list is. So if your list is 5, this becomes 5. If your list is 10, becomes 10. If your list is 3,000, then this becomes 3,000. So this is definitely a more useful way of doing this. And thinking back to what one of the goals of this video is, which is to teach you, okay, you know, you can create functions that use functions. Well, there you go. We're using the len function from Python in our function, mySum. So what do we do here as we go through the list? We have to add them up. So this becomes my list bracket I. Okay, so that's just part of the process. Usually in a scenario, you won't be given the process. It's assumed that you understand what the process is. And again, this is something that we've done in a past video when we're talking about lists. Now, if you see the scenarios, again, the way we write them, if you see the word returns, that means that somewhere in your function, you need to have the word return. And what are we looking for you to return? We're looking for you to return the sum. So I'm going to do S, and that's it. That's our function. So now let's test it out. Let's go back to our main program, and now let's do a print of my sum of grades. Okay, so we're taking the grades list, we're passing it to the function. So this list gets put inside this variable, and then it calculates all the information, and then it returns S. It returns S right back to this spot. So whatever value the S is, it will come back to this spot. So let's do a quick sum here. So 100 plus 90, 190, 190 plus 80, 270. And you always want to double check your work manually, just to make sure that everything's correct. So let's run it. Let's see what happens. 270. So our function works. And just to kind of show you the flexibility of this, let's say I added another 100 to this, which just makes it an easy sum. Should be 370. Notice I'm not going back to the function to change it. And the reason for that was that our function calculates the length of the list each time. So it doesn't have to be hard-coded. All right, so we got that done. So now let's do the next function. And let's kind of practice a little bit of that reading of the scenario. So create a function. Cool, DEF. My average. All right, so that's the name of the function. It's a function, so I put the parentheses and the colon automatically. That accepts a list and returns the average of the list. Okay, so you might be tempted to say, okay, an average means we have to add up the items in the list and then divide by the total amount. You could do that. You could redo all this work. But why don't we do this instead? Let's simply return, because what is the average? It's the sum of the grades, or the sum of the numbers divided by the total number. So I can do my sum of, oops, forgot. Let's put my list here. My sum of my list divided by the number of things in the list. Well, you kind of already saw how we could get how many things are in a list. That's this. So because we've created functions, because we have functions available to us, this function became so much easier. Look, there's practically no code in it. It's just a return statement that says, call the mySum function with my list. It's going to do the calculation of the sum of the list, return the value to here, then it's going to divide by how many things are in the list, and it's going to return it back. Okay, so let's go back to our main program, and now let's do this. So let's do a print of, and I'm going to keep it simple just so we know that the average is 90. So let's do my average of grades. So before we run it, so grades is the list. It's going to be sent to the myAverage function. MyAverage function takes the grades, and now it passes it to the mySum function. The mySum function does its calculation and returns it back. Whatever the sum is, which in this case would be 270, now it takes it and calls the len function, which comes back as 3, and it takes 270 divided by 3. It should give us 90, let's see. And there it is, 90. If you find this a little bit hard to understand, think of it like passing notes in a class. Kind of dating myself. You guys don't pass notes anymore. You text everything. But back when I was in school and we didn't have phones, the way you got a message across to your classmate in the other side of a room was to write a note on a piece of paper, ask your friend to pass it to that person, who then passed it to the other one. And then when that person wrote it back, it kind of came back to you. That is the idea of functions. Functions are called functions. That one passes the information to the next one, passes the information to the next one. So ultimately somebody gets it and then returns some information back. So that is how you can call functions from within functions, which hopefully you see makes the code a lot easier. Now I want to show you something else. Because we've kind of stayed away from the word sum. The word sum is this function. Python found that there were so many instances of people wanting to figure out the sum of a list that they actually created a function. So what I could do here, I can call the sum function that comes from Python with grades. And let's see what that does. There's a 270. So instead of creating this big sophisticated function we had here, we could have just used the function sum from Python. The reason we went through this exercise anyway was because we wanted you to see how you could take a process that you already knew and create a function out of it. And also the fact that when you move on to other languages don't have these nice little functions available to you. So this is a good example of how you would do it in those languages. How would you create a function that takes the sum and returns it? So let's kind of continue on here. So I didn't have to create the average function either, because what was the average function? It was the sum of the grades divided by the length of the grades. So we're kind of going around full circle, where we've kind of taught you to create functions to encapsulate a process, but now I'm showing you how in Python, in this particular example, you didn't have to do that. But it's still the idea that you're using functions to call functions. So an average function really is just this. That's all it is. And there you go. So you got the 270 and 90 using our functions, and then we got the 270 and 90 using the functions from Python. Right. I want to do one more example of functions, which is, if you ever notice, every time you read an integer number, you had to, read the input and then convert it to an integer. Wouldn't it be cool if you did something like this? Let's say age is equal to read integer, and then maybe pass it a message. Say enter integer. Okay, and then we could simply print the integer out. Let's say print age. Okay, so right now that's not going to work. As you can see here, it says read int is not defined, because again, it's not part of the language. It's something we would like to do. So let's go to our function and let's create a function to do that. So let's say def read int. So we're kind of doing a little bit of reverse engineering here. This is what we would like to be able to happen. Now we know internally that means that we have to, maybe create a variable called info, do the int input, and then whatever the message is. So let's have it as message here. So that way, if the person decides to write something else, and you know what? I'm going to do this in two separate steps. Just kind of. So input message. Well, what's the message? The message will be whatever they put here. So read int and some message. In this case, we're going to do enter integer. This gets passed on to the read int and this variable, this parameter, which then gets put into the input statement. But the whole purpose of this is that we could avoid having to do int, have to write int and input. So we can do a return now of int of the info. So here's another example of us using functions within functions. So we created our own read int function, which is going to use the input function from Python, which is then going to use the int function on the input. Right. So let's see this work. And honestly, at this point, I think I'll rather do type, just to prove to you that when we do enter in a number, after we've read it, we're getting an integer. Because if you recall, anytime you use input by itself, it's string by default. So let's do this. Let's do 90. Oh, I didn't realize I put age, though I'm just entering an integer. My age is not 90. But you see here, what we get back is an integer. Read int returns an integer, which is what we need. All right, so let's go back to our presentation. And in this lesson, we've taken the idea of functions a step further in that we explored how functions can use other functions to accomplish their job. And honestly, when you go further into programming, that leads to a part of a bigger concept called object-oriented programming, which means you kind of encapsulate everything into some kind of an object, and then you work with that object instead of working directly in some big monolithic, segment of code. So hopefully this has been a better example of using functions. Again, the only way you're going to get better at it is to do it. So good luck, enjoy.